The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody. Welcome to the Rodalec and Banner webinar on laser measurement sensors. Your host today from Banner will be Dana Holmes. She's a senior product marketing manager. I guess I'll hand it over to her. Dana, go ahead.
Great, thank you so much. I appreciate you giving me the opportunity. Today we're going to talk about Banner laser measurement sensors and how we can help you solve your toughest applications.
Sorry, actually one more point too. If anyone does have any questions in the questions section there, if you want to do those throughout the show, we'll either answer them as we go or at the end.
Perfect, thank you. First of all, Banner laser measurement sensors have been designed for your type of applications. They are designed to excel in the harsh environments of industrial automation. And the other thing we've done is we tried to remove some common sensing barriers to make our sensors easier to commission and easier to utilize to solve the toughest applications. Our laser measurement portfolio consists of 5 different product series with multiple models within each series. And each one of these has been optimized for performance, whether that be on range, on precision, materials as ruggedness, whether it's a stainless steel housing or if it's a plastic or a metal die-cast housing. So we have multiple sensors to solve your applications. One of the things we made was a flow chart to kind of make it easier for you to determine which sensor is the best one for you to use. Our Q4X is our flagship laser measurement sensor. It is a stainless steel housing and it has many models with different options within them so that you can solve the wide variety of your applications while using a Q4X. But if you need longer range or more excess gain and better precision beyond 100 millimeters, we have recently come out with about a year ago, our Q5X series. It's built on the same principles as a Q4X, but what we've taken is a little larger design, and we've taken that range where it ended at 600 millimeters Q4X. We're out to 2 meters now. And sneak peek, we're going to have a 5-meter version that's going to be released next month as well. But if you need better temperature stability, higher precision, a larger display, or for now, analog, because the Q5X will be coming out with analog in August. Right now, we have our LE product series. The LE is that higher performance sensor series. It has 2 different versions, the LE 250 with a 400 millimeter range and the LE 550 with a 1 meter range. But if you need the absolute best performance with the best temperature stability, highest excess gain, a very small spot size, and a smaller housing, we do have our LM series. The LM is our highest precision series, but it does only go to 150 millimeters of range. Now, if precision isn't where you need higher precision from the Q5X, we also do have our LTF series. Our LTF series is our long-range sensor series, and it goes out to 24 meters. And it does have excellent precision beyond 1 meter. But today what we're really going to talk about is the real benefits of the Banner laser measurement sensors. We're going to talk about our precise detection capabilities, the extended range, visible beam, high speed, high excess gain, and more features that we pack into these sensors. I think this will help you understand exactly why what we've done with our sensor design, optimize them to help you in your applications. So first, precise detection capabilities. We have designed the Banner laser measurement sensors to optimize performance. We have resolution that goes from 2 microns to 12 millimeters to solve every application. Now, I know everybody would say, well, why don't I just use a 2-micron sensor for every application? Well, it's not really necessary. And there's a trade-off between cost and performance, and as well as range with the different capabilities that we have. One of the things that we've really done with our sensors is we've optimized them to detect challenging targets, not just white cards. A lot of times on sensor specifications, you'll see performance on a white card, and we do have that as well. But when they're talking about that, they're talking about in a perfect lab environment. You're taking your sensor, you're not moving it, you're not moving your target, and you're looking at a white card. What we try to do is be a little bit more realistic so that you will understand how the sensor is going to perform in a dusty, dirty factory environment or with a lot of moving parts, high speed. So we've optimized our sensors to be able to detect round objects, uneven objects, shinier metal, that's a big tough one, dark surfaces, multicolored. Marketing departments keep making packaging much more multicolored and reflective to get people's attention, and that becomes a challenge for sensors. And then clear objects as well also provide challenges. So what we've done is we have specifications that we have chosen that really help you optimize your performance and help you choose the right sensor for the right application. So discrete laser measurement sensors for those discrete applications, repeatability, and really minimum object separation, the specifications that are going to tell you how that sensor is going to perform in your application. For analog, resolution and linearity. And it's really linearity. Linearity is really going to tell you, you can teach your near, you can teach your far. As long as it's linear, you can account for any type of offset that you might have. And then IO link. IO link, we have repeatability, accuracy, and linearity can come into this. But accuracy and linearity are really the specifications for IO link that are going to help you get to where you need to be. Now, this is a whole nother presentation that can take hours and is a nice boring topic that puts many people to sleep. But you can find all this information on bannerengineering.com. You go under products and then under laser measurement sensors, you will get to a page that talks about the discrete, analog, and IO link. And there's a white paper there that you can read that goes through why these are important for different applications. We also have their laser measurement charts, and these are done by the type of applications, discrete, analog, and IO link. And these are downloadable to give you a quick glance so that you can see which sensor you need for your application. And what we've done is we've done it by range, so you can very quickly go, okay, I have a 1 meter range application. I can use the Q5X. I can use the LE550, the LTF12, or the LTF24. Okay, now between them, which one's going to meet my needs with my repeatability or my minimum object separation. So it's just a quick at-a-glance tool to help you. Temperature effect. One of the things that we do is we really design our sensors to have minimal temperature effect. And I'm not talking sensor warm-up time or anything like that. What I'm talking about is the changes in ambient temperature when we're talking about sensors in an application. Think about your factory. You walk in the morning, the lights are off, nobody's there, it's kind of cold, it's dark. So as people come in, the lights turn on, then the machines come on, maybe the temperature warms up outside. We can have substantial temperature shifts within that factory floor from the morning until the afternoon before we go home. And that can affect our laser measurement sensors and the detection we get from it. So what we do is we really try to minimize that temperature effect so that you don't get additional error in your applications. So we're going to talk about a couple different applications that we've solved. In this application, this is our LM sensor, and this is a molded wiper part that was being manufactured. And the customer wanted to verify the tolerance of that molded piece as it came out. So what we took was had 6 LMs all around around the piece part, making a measurement, and 1 RSD. And the RSD is this little black piece over here with a display, and that's a remote sensor display. And what that does, it allows us to program because the LM does not have buttons, and it can be programmed either by remote teach, IO link, or using a remote display. The neat thing about this remote display is it is able to come off after you program the sensor, and the sensor will save its configurations. The other thing with the RSD is it also allows you to save up to 6 different configurations. So in this case, what the customer did was they took 6 LMs, 1 RSD, they saved all the settings for each one of the LM sensors on the RSD, took the RSD and put it in the panel, hid it away, so if they would ever have to reprogram the sensors, those settings are already saved, and an untrained operator can just hook it up, choose which sensor needs to program, and automatically program it. In this application, the LM was a successful sensor because the LM can detect the 2-micron height variation, even on a shiny or a black target. And it was very compact size, so it was easy to integrate into this small space. Oh, I should also say that remote sensor display, it was designed to work with the LM to make sure that we were able to program it, but we've also added on that it now works with our Q4X600, our Q5X, and our LTF sensors. So if you ever have a sensor that's buried away, or I have one customer that has them mounted up in the rafters looking down, but they want to see what the sensor display is, this is a really great way to replicate your display or save configurations. In this application, we were measuring the cardboard thickness. The challenge was the equipment adjusts based on distance changes, so it automatically changes, so it needs to get that real-time data. The temperature in the facility varied quite a bit throughout the day, and they also wanted very simple sensor configuration. So what we used was the LM, and it has a very linear output, so it gave that direct process control based on the height changes. It also has best-in-class temperature compensation. Compared to the competitors, its temperature stability is about, or its temperature effect is about half of what we see in other sensors. And then through IO-Link, the PLC can adjust the configuration of all these sensors simultaneously. This is an application with our Q4X. Basically what they're doing is they're error proofing in automotive. You can see the sensors are looking at the part, and they're verifying that a very small gasket's in place. The Q4X works very well for this because it can detect an object as thin as 1 millimeter. And you'll notice these nice bright indicators here on this. This is a new product that we have, our S15L. It's an inline indicator that can give you some really good visual feedback of what's going on from your sensor from far away. So even across the factory floor, if you take a glance over here, you can see what's happening. Extended range. Banner Engineering has sensors that go from millimeters to meters of detection range. So we can go from 25 millimeters out to 24 meters with these standard laser measurement products. These are non-retroreflective, so they don't need a reflector on these. These are just diffuse mode sensors. We use two different types of technology. We use triangulation, and triangulation is really good for short range and precise type applications. Basically, the laser shoots out, it hits our object, and it comes back through a lens, and depending on where it lands on the receiver array, we know how far away it was. You can see the angle is different when the target is in closer versus far away. So this really is, like I said, short range out to about 1 meter. Triangulation is very effective. And then for longer range, we utilize time of flight technology. So time of flight, basically our sensor, our laser, our beam comes out, hits the target and comes back. And depending on how long it takes to get there and get back, that's how we know how far the measurement is. So this helps us, like I said, on those longer range applications, but not quite so precise as the very short range sensors. In this application, this is our LTF series, and this is a series that has versions that go to 12 meters or 24 meters. What we're doing is we're doing pallet collision avoidance on a palletizer. So we want to detect large pallets on adjacent conveyors. So these are exposed to a lot of vibration and shock. And then we also have sensors that are mounted very close together. You can see for 2 pairs mounted very close together in different locations. So the LTF 12-meter range spans the length of the pallet conveyors, so it takes care of that range on these big conveyors. We also have a rugged metal housing that's resistant to shock, and we've actually increased that shock resistance from 40 Gs to 100 Gs in the last year or two. So we're very rugged in those high vibration applications. Also, the LTF has advanced crosstalk algorithms, so you can mount these sensors next to each other, and we're not going to have a problem with one of the sensors triggering another sensor. And then my favorite part of the presentation, visible beam. No laser measurement presentation is complete without a shark with a laser beam, in my opinion. So we use a visible red beam to allow easy alignment and measurement of specific targets or features. One of the other things with the visible beam is we do utilize a variety of beam spot sizes for consistent detection. We want to make sure that we can optimize that beam spot for your application. A small beam spot minimizes measurement variation across color transitions. So we're talking about those nice, bright, colorful packages that are that like to trick up sensors. If we use a small beam spot, it can it makes it much more stable. That small beam spot can get one color at a time versus possibly getting over multiple colors and making our measurement not as precise. Also, a small beam spot is really ideal for precise profiling of small features. So if I have a rough or uneven target, that small beam spot can get in and tell me that precise measurement right at that feature that I want to look at. When I have a larger beam spot, what it's going to do is it's going to average over that, that spacing there. So we're not going to get really precise details on a specific location that you're looking at. But conversely, a large beam spot provides that averaging across rough surfaces for more measurement stability. So think a wood or some sort of uneven surface, even some metals. So what it does is it kind of looks across and gives us that nice average versus maybe we're going to get into a peak or a valley of that rough surface if we had a small beam spot. In this application, we're doing error proofing on electrical assembly, and we used our Q4X sensor. This one is a 600 millimeter range sensor, so we can get it up out of the operator's way. So the sensor shines a target. You can see the nice bright beam spot right on the assembly, and it tells the operator where they need to put the piece part in. And then once it's in and it's in the correct location, the sensor says, yep, you're good to go. We have some touch buttons up here so that they can move on to the next operation. And that Q4X can detect the small changes in position very easily. So it makes sure that these clips are seated within the assembly. In this next application, it's another error proofing application utilizing our Q4X. Yeah, there we go. We've got a bunch of Q4Xs and I've simulated our beams here, but you can see the spot on the clips and it's making sure that they're all inserted and they're all lit up. There we go. They're all inserted and they're inserted properly. So this is easy to maintain. One of the things also that's nice on this is we've got these bright LED indicators. So very quickly and easily, the operator can see that the sensors are all saying, yep, everything is A-okay. High speed. High speed can be very important. We have measurement update rates as fast as 250 microseconds for your fastest moving applications. In a lot of applications, conveyor speed, you want these things to go as fast as it can to get more product out the door. One of the things we also do in our sensors is we have adjustable response speed. So you can go into the menus and you can change the response speed depending on your application. Because the higher the speed, you do sacrifice some excess gain. But if you can lower your speed, you can increase your excess gain. So if you have an application that really isn't that high speed and you have a black target, slow the sensor down as slow as you can get away with, and you're going to have the highest excess gain, and you're going to have a very robust sensor. In this application, we're doing package profiling in a high-speed application. So these are going right through. And what we want to do is we're profiling these to make sure they're scanning the packages to ensure accurate and fast sortation. So you have a wide variety of color, size, and sheen of your packages. So what we did was we had an array. We mounted 8 LE sensors above the conveyor belt across here, looking down onto the packages. And what that did was help determine the size of the parcel and ensure it gets sorted to the correct conveyor. And we also verified that each package had 4 sides or corners, confirming that it's a single item and you didn't have 2 items kind of pushed up against each other. The LE was an excellent choice in this case because it does have a very fast response speed, 5 to 10 milliseconds. and each sensor operates independently, the response speed is significantly faster than a light grid that could be used in this type of application. So this gives us greater accuracy at these high speeds. High excess gain. You hear us talk a lot about excess gain. Excess gain is that minimum light energy needed for reliable sensor operation. One of the things we do is we have automatic gain compensation, as well as the highest excess gain in class with sensors. So other sensors can get oversaturated and experience increased error when we have a shiny target, like a metal or something with some sheen on it. But what we do is our laser sensors automatically decrease gain whenever they see they get too much light back to maintain the accuracy. Conversely, whenever we have a dark object, we have a really weak signal back. We can get a weak signal back from them. So the laser sensors automatically increase their gain to make sure that we amplify that received signal and we can reliably see targets that others can't see. The other thing that high excess gain allows us to do is reliable detection with mounting flexibility. So here you can see we can mount at all different angles. And I think this is where I talk about this, but the number one thing that is that solves 99.999998% of all application problems is tilting your sensor. Laser measurement sensors perform better if they are tilted. And if you look in the instruction manuals, it will tell you 5 degrees is even fine, 5 to 10, 15 degrees. Just get a little tilt on that sensor. Try not to have it completely perpendicular to the target. And what this does is it keeps some of the light that maybe from a reflective surface or a shiny surface from coming back and tricking the sensor. So you're going to get a much more accurate reading by tilting your laser measurement sensor. I had a customer tell me that, oh, he had no shine, there was no sheen, no shiny, it was just a very nice matte piece of metal he was looking at. Well, metal inherently has some reflective properties in it. So by tilting the sensor, all of a sudden the sensor works fantastic. So don't forget, tilt your laser measurement sensor.
Sorry, Dana. Now, is that's specific for kind of the competitors as well, or is that just for Banner?
Well, I don't know about their sensors. I imagine it's just a thing for laser measurement sensors, honestly. But like I said, always use Banner laser measurement sensors.
All right, thank you.
I think it has some good uses. It is definitely just technology driven. So,
I think
high excess gain. This is an application.
No, I would say that I think in general the other laser sensors, they don't work as well as Banner sensors, so you cannot compare those, right? But I think
Exactly.
This is just a joke. This is just a joke, but I think it's because it's laser. So, and what happens is
yes,
it's blinding the sensor, and that's why it stops working.
Yes.
So it's too much light to the sensor, and then when it's directly back, yeah.
Okay, so it's just the technology itself.
Exactly.
Fair enough. Thank you.
Exactly. It just has to do when you have a shiny or reflective object, a lot of light comes back at it. And it's not the exact light you want from the specific area where you're trying to measure. So this application, this is one of my, this is a nice application with our Q5X showing the very high excess gain. In this application, it's tire compound detection. It's in a press. So the customer had been using another sensor and wasn't satisfied with the performance. And of course, tire material is very, very dark, and the area is dirty and dusty and just kind of a nasty environment. So the Q5X, we were able to put it in there, and with its extremely high excess gain, it can reliably detect that black target. This is another one that was a really great application. This is a customer who is making wallboard, and in the manufacturing area, it's very dusty, and so they were cleaning the sensors. They had people go around to every sensor in their factory, I think once a week, to clean these sensors off because it was so dusty. So they decided to give the Q5X a try on this. And so what they did was, instead of putting it in their regular production facility on the lines, they have a room where they would take the damaged wallboard and cut it up and make pallets out of it. And that room was a smaller, closed-in area. The ventilation wasn't as great as it should be, so the dust buildup in there was substantially more than anywhere in the factory floor. So they put the Q5Xs in there, and they left them for a month and came back, and the sensors were functioning fine. Even with the buildup of dust on the lens face, because it has such high excess gain, the laser was able to burn through that and still detect the wall board as it needed to. So what they did was they ripped out all the other sensors that were on the factory floor and replaced them with the Q5Xs. And of course, they're probably going to have to change, to clean the lenses periodically, but it's not once a week. Maybe it's once every couple months. So that saves them a lot of time and labor. More features. This is something that we're very cognizant of when we're designing sensors. What we want to do is we have multiple functions in one sensor. And what this does is helps you reduce inventory. So you can use a single sensor for different applications just by going in and utilizing the menu structure in there. Some of our competitors will have a sensor that's optimized for shiny, one for clear objects, one for high speed, one for low speed. We put that all in one sensor. In our Q4X and Q5X, for example, we have 5 different sensing modes to solve your applications. We have a background suppression, foreground suppression, a 2-point teach, dynamic teach, so you can teach it on the fly, and then we have something unique, dual mode. And what dual mode does is it takes distance and intensity data to detect any change. So one of the easiest applications for it is clear object detection. Because we're looking for that intensity change, we teach a stable background, and it'll detect any object that comes in front of it. So transparent objects, and we don't have a need for a retroreflector. Like I said, all we need is a stable background. We can also do extended range because we're looking for that distance and intensity. We can teach the sensor, which has a 600 millimeter maximum range in this series. What we can do is we can teach it beyond that range out to a background, and anything that comes between there, it's going to detect. And not measure when dual mode, but it's going to detect it and tell you if something's there. I think we actually set one up on our sales floor and shot it across a room that was, how big is that room? 50 feet? Yeah. Like 50 feet, yeah. So it's it can go well beyond. You just have to make sure, like I said, you have a nice background to teach it. The other thing that this is really good for is error proofing. What we can do is I can use it. It has dual outputs, so we can change them to detect one for detecting distance, one for detecting intensity, to verify a color. So in this case, I've got, what I'm trying to do is I only want to have one part there, and it has to be a gray color. So I passed my distance and I passed my color. In the next one, my distance is not. I have 2 stacked up. It's the right color though, but that's going to be a fail. This last one, oh, it's not the right part. It has a black key. It's black instead of gray, but it is the right distance. I'm still going to fail. So you can use it to detect contrast differences. So that intensity reflects, so it can kind of be almost like a poor man's contrast sensor, but it does do simple contrast applications. One of the other features is something we just officially released yesterday. It's called Pulse Pro IO. And what Pulse Pro IO does is it allows us to collect distance data direct to a PLC using pulse frequency modulation output. So what these are is they're digital PMP pulses scaled between 100 and 600 hertz. And by using a counter, a digital counter, which is a lot of times standard on your PLC, you can take the distance data straight to a PLC without having to use an analog input card. It also can tell you that we have a loss of signal between the target and the sensor, and it has increased immunity from electrical noise. And what this means is you don't have to use shielded cabling in an analog application. So that's one thing with Pulse Pro IO, and this is in our Q4X, our Q5X, and our LTF sensors right now standard. It's just part of the menu structure. You can choose a PFM output. The other thing we can do with this is we can do a direct distance visualization with a banner light with no PLC required. I've got an animation that'll kind of explain it, but all you need is your sensor, a splitter, power, and then you take it to a banner light, and it can be configured how you want it with free software that's downloadable off of bannerengineering.com. So here's a nice visualization. So what I'm trying to detect is I've got a truck backing up, and I want to make sure it doesn't hit here. So I've got a big light that's turning red and tells exactly when to stop. So this is nice for, like I said, visualization for operators using on fork trucks, even hopper fill level. You can have a light up there that can show the operator that, hey, I'm getting empty on this, I need to refill. So it's just that, and it's very easy. It's plug and play because, like I said, we don't need a PLC. All of the smarts is in the software, in the lights, everything, and just taking that direct distance data from the sensor. There we go. Very nice. So multiple functions in one sensor. I talked about this a little bit earlier. We have dual discrete models. They eliminate the need for multiple sensors. So I could basically do 2 measurements in one sensor. We have bipolar outputs. So you don't have to select if it's NPN or PNP. You can have a user selectable response time. So you can speed up the sensor or slow down the sensor depending on your application. Also IO link. Once again, a whole nother presentation we can talk about, but IO link will reduce your overall costs, increase process efficiency, and improve your machine availability. There is a section on bannerengineering.com if you want to look at, I think it's product capabilities. Under there is an IO link page. It gives a lot of great information. So in this application, I've got my Q5X in dual teach mode, and I want to detect clear bottles. The Q5X, remember, has a 2-meter range, so we can see across a wide conveyor. And we want to detect the bottles that have moved before another layer is swept onto the conveyor. Moving bottles can have an unstable signal, and also clear objects have a very low contrast, so it can be challenging to detect. Our Q5X, actually, we have integral timing logic in there, so we can filter out the small gaps between the bottles as they move kind of together in a cluster. That dual teach mode, because we're detecting distance and light intensity, really detect the presence of clear bottles without the double count. In this application, this is another example of our Pulse Pro IO. What I've got going on here, I've got a forklift, and our forklift operator, his line of sight's obstructed because he's got a very high stack of material here. And he's trying to bring the material into his drop zone. So what we have is we have Q5X sensors mounted to the drop zone structure with our WLS27 strip lights on the top and the right sides of the drop zone. So when the operator comes in, there's a Q5X sensor here, and there's also some on the front end of it measuring how he's coming in. We have our distance mode, and our WLS27 is going to change color here based on the proximity of the forklift to the front of the drop zone. So this light here is connected to the sensor up here. It's telling them, oh, I'm in far enough, I can stop, so I don't damage the material or the drop zone. Then what we have up here is we have these Q5X sensors connected to the gauge mode WLS27s. And so what this is going to do is let them know their alignment horizontally. Are they too far left? Are they too far right? So that they can make sure that they get it centered and the product goes exactly where you want it to be. So once again, plug and play. We don't need a PLC, and we're giving that nice visual indication to avoid product loss and damage. This application, our Q5X, utilizing our dual discrete output. And this was a real application that we solved. We had a customer that needed to mount their sensor about 1.5 meters away from a bumper assembly. And in that bumper assembly, there were 2 pieces inserted on top of each other into the black bumper. So we had a black bumper, and piece 1 was black going into it. And then the second piece was gray and very, very thin. So 2-meter range without a reflector, our Q5X can do, not a problem. What we used was dual discrete outputs. So our output 1 was able to detect the small black part on the black background using just a discrete distance. But then the second part, the very thin gray part, out at about 1.5 meters, it was a little too thin for us to detect. What we did was we used dual mode. And the dual mode verified that that gray piece was there because it could see the difference between the gray and the black. So that way we were able to error-proof this assembly operation for them. And the competitor was utilizing 2 different sensors that had to be mounted in a little closer. So we were able to take this business and help the customer solve it and be much more economical. IO-Link, this is our Q4X series sensor. It is doing automatic case packer and case profiling. So depending on what size cases, the sensors automatically needed to change their settings during the product changeover. And we're verifying the case position and making sure that cases are identifying cases that are outside of specification. So through IO-Link, the PLC can automatically send the Q4X the new configurations depending on the size of the cases that we're running. And then we can measure that case position within 1 millimeter. And of course, there's 2 different sensors here to detect the large variations in the case stack. So a lot of different benefits. Like I said, we've designed these sensors intentionally to help you overcome challenges with laser measurement sensors. And we have a sensor for every application. And we continue to add on different capabilities and different modes in these sensors. So keep your eyes and ears open because in the next couple of months, we've got some good stuff coming for you. Thank you very much. And if there's any questions, be happy to answer them.
Thank you, Dana. It was a great presentation.
Yeah, Dana, thank you very much.
You guys are so welcome. Thank you for having me. And like I said, if there's any questions, please reach out. We're happy to help you.
Yeah, your main point of contact, I think, is first going to Ben, and then he will come to me. I'm field applications engineer at Ben Canada. My name is Ariel. And then if I have questions, I can go back to Dana or the apps group in the US.
Absolutely, yeah. ben.reed@rodolec.com or 519-761-2181 to get a hold of me. Thanks, everyone.
Thank you very much.
Thank you. Have a good day.